recording now. Okay, thanks everyone for joining. I'm Shams. This combined peer-to-peer tutorial was prepared as an introduction to the programming language R. The target audience for this presentation are people who are not that familiar with R, but have sufficient general coding skills. Throughout this presentation, if you have any question or have technical difficulties, feel free to type them in chat and one of us will try to solve them for you. Okay, so while preparing this presentation, we actually did a survey, including several combined fellows with Daniel's help, and we asked which topics would be most beneficial to include in this presentation. From the responses, we decided to cover 6 key discussion points. They are introduction, install R, data type and data structure, statistics, data visualization, and the use of R Shiny. First, I will cover the introduction to R and how to install R, and afterwards, other group members will cover the rest of the discussion points. R is primarily a scripting language, which is used mainly to visualize, manipulate, and analyze data. It was developed by 2 researchers from New Zealand, and the name R actually comes from the initials of the creators of this language. As you can see from the graphs on screen, the use of R is increasing very rapidly, and it's currently one of the most widely used programming languages. One of the main reasons of using R is its ease of use. Thousands of different libraries are available to download from the CRAN repository, and you can use these R libraries to connect with other programming languages to visualize data, analyze data. You can do deep learning with R and also build web applications. Also, if you're interested to work in tech companies, it might also be very helpful to learn R, as more and more of them are adopting this language. To install R, you can directly go to the CRAN repository and download the appropriate installation package. If you're planning to learn R, we recommend that you use an IDE. You can use an IDE on your local machine, for example, RStudio, or you can also use web servers, for example, RStudio Cloud or Google Colab. In this presentation, we will be using RStudio Cloud, and most of you should already have an account there. There are many advantages of using an IDE. For example, if you would like to install a package, all you need to do is to search for the package in your IDE and click install. Okay, so next I will briefly introduce you to the RStudio Cloud user interface. So when you open a new project in RStudio Cloud, you will see a few panels. So the big one by default is console, and here I will demonstrate a simple addition operation. So as you can see, while I was using these 2 variables X and Y, they are showing up in this environment tab where you can keep track of how these variables are changing. There are also other useful panels. For example, you can check your command history, you can plot figures, and you can also search for different packages. So now Wei will cover the next discussion point, and we'll demonstrate this in more detail.
Hi, everyone. My name is Wei. Well, I'm going to lead you through the very basic of the data type and data structure. So here is just the outline and list what data type and data structure I'm going to introduce you through. And after that, I'm going to briefly introduce a useful package, which is called dplyr, and it is used for the data wrangling. So I'm going to do this use a R Markdown file, which contains the descriptions and as well as the codes. So it's easier for you to, it's more straightforward for us to go through it. So the resources for this tutorial is listed here. If you need more information, just feel free to check them. So let's start with the data type. If you use some other kind of coding languages, you might be already familiar with them. So in R, we also have character, like here are some examples, just like string in Python, and numeric, we have some numbers, and integer. And in R, we use the L to tell R to store this as an integer, and also the logical data type. So here are 4 examples. You can always use the type of to check what type it is. Oops, sorry. So if you run this chunk, it will tell you the first one, the UMD is a character, second one is a double, third one is integer, and last one is a logical. And next one is the data structure. And I'm going to introduce you these 5 data structure one by one. And the first one is the vector. So the elements of the vector must be of the same data type. And let's take a look at the example. Now I want to initialize a character vector that contains 5 characters. Because I didn't assign it any specific characters, so it's the default character is the empty one. So here is a vector that contains 5 empty characters. So we can also use another easier way to do the same thing. We can use the data type name to directly do this initialization. And let's see what this 3-line code will give us. The first one will give us the exactly vector as the previous code. And second, numeric will give us 5 zeros because the default for the numeric is 0 and default for the logical is false. So here is a vector with 5 false logical characters. Of course, you can also assign your own data to a variable name. So the C command here will return you a vector. So for example, here, x equals to C123, it will give you a vector that contains number 1 to 3. So Y is a vector, is a logical vector, and Z is a character vector. The next one, the second data structure is the matrix. And in R, the matrix are an extension of the numeric or character vectors. So which means in the matrix, all the item in the matrix must be of the same data type as well. So let's take a look at an example. We initialize a matrix that contains 2 rows and 2 columns. And this matrix will look like this. And the dimension of the matrix M is 2 by 2. And let's add in some data. So I want to add 1 to 6 into this matrix. And please give me 2 rows and 3 columns. And if you look at here, and you will see it will fill in the matrix column widely. So we have 1, 2, 3, 4, 5, 6. And the dimension of the matrix is 2 by 3. And the one thing that's different between the R and the Python is the index of R start from 1 instead of 0. So if you want this number 6, you have to tell it to give me the number in the row 2 and the column 3. So M23 will give you the 6. And a special data structure of R is called factor. And factors are the R objects which are created using a vector, and it stores vector along with the distinct values of the elements in the vector as labels. So which means it is a vector, but it also has some labels that labeled item in the vector. It might be confused. Let's take a look at an example. So let's create a vector first. So vector is called the apple colors, and we have 7 apples here. First 2 are green, third is yellow, 4th, 5th, and 6th are red, and last one is green. And then we force this vector into a factor. So the factor apple, we're using this factor to turn this apple colors vector into a factor. So now let's print this factor. So the factor apple you will first see the vector here, and it will tell you you have 3 levels, which are the 3 distinct colors in this vector. And if you print the how many levels do I have in this vector, it will tell you 3. So if you want to know more like how to make use of this vector, just check the resource link we have at the beginning. It will tell you more information about that. And the 4th data structure is the list. And the list is different from the vector, and because the list, the content of list are not restricted to the single data type. So the element list can be any type of our object, even list containing further lists. So here I have a list called X, and you can see it contains 4 different data types. And I made another list called X lists. The first item of the list is UMD, which I can assign it a name called column 1. And second item in the list is numbers 1 to 10. And third item in the list is X. And then remember, X is a list as well. So here is an example of list that containing the list. So we have UMD, 10 numbers, and another list. And the last data structure is the data frame. And data frame is super important in R, we use it a lot. And data frame is a special type of list where every element of the list has the same length. So data frame is actually a list. Let's take a look at an example. We create a data frame called dat, and it is data frame. And the first column is called ID. It contains 10 letters. And second column is the name is X, and it contains 10 numbers. And third column is Y, contains 10 numbers as well. Let's take a look at what the dat look like. So great, we have 3 columns here. And it also kind of tell you what the data type of each column here. So first is character, then it's integer, then it's integer. So remember, the data frame is a list. So let's use this code to test whether this dat is a list. Well, it tells you yes, it is a list, and the class of the dat is a data frame. So sometimes you want to extract 1 column of the data frame. You can use this $sign. So you can write the data frame name first, followed by a $sign, and followed by the column name. So this column, if you extract column in this way, this column is not a list. So if you test, is it a list? No, it will tell you false. And if you ask if it is a vector, it will tell you true. So when you call a column using this format, it will return you a vector. And the class of this column, it will tell you it's character. So let's take a look. R has some embedding data frame for you to practice how to use in R. And here we're going to load one of them. The data frame is called iris. And let's load it. And you can see the, well, oops, I cannot find the iris. It will show in this environment. So simply you don't need to click, you don't need to type the view, you just need to click here, it will show you the data frame. So this is the iris data frame, and we have 5 columns, and here it will tell you how many rows you have in the iris data frame. So this is all for the data type and data structure, and let's briefly introduce this package, which is called dplyr, and it is used for the data wrangling, and we have resources here. And every time when you need to use a package, you have to load it first. We have already installed it, and you can install it here or use command line. So we run this to load the package, then we can use this package. The special thing about dplyr is that it has the symbol called pipes. The function of this symbol is to take the item in the left side as input and input this thing into the right side, into the function in the right side or some actions in the right side, and it will do the work for you. So let's take a look. The iris, we have a column called the sepal length. So it has numbers in that. Now we want to know what's the average of this sepal length. So remember, we use the $sign to extract the column. So now we extract this column and that's it to take the mean of this column. Let's run it and it will tell you the average of the sepal length is 5.84. But what if you want to know, because in the iris data frame, it has different species like Setosa here and versicolor. So what if you want to know for each species, what is the average sepal length? So you can do this, use the verbs in the dplyr, and you can use it. You can use the group by. So you take the data frame, you group by the species, and you summarize it, take the mean of the sepal length for each species. And if you run this, you will see that it gives you have 3 species in this iris data frame, and the average sepal length and mean petal length is look like this. I don't have enough time to go through all the verbs one by one. Here I list the 5 core verbs, but there are a lot extra verbs in this package. So we also give you the cheat sheet link that you can download. And if you use dplyr a lot, feel free to print it out and put it on your table. It's easier for you to check it out. So the next part is the statistics. Let me give it back to the Leslie. So the Leslie will video go through the statistics.
Okay, so I think I have control, yes. Okay, so next I will introduce the topic of using R for statistical analyses. There are many useful R packages for statistical analysis. A few commonly used packages include tidyr, which is used for simple data manipulation, for simple data transformations, dplyr, which is used for data manipulation, and the psych package, which is used for data analysis. If you've never installed these packages before, they can be installed using this sample code on the right. Every time you start a new session in R, you will have to load the packages that you plan on using by typing library, followed by the name of the package in parentheses, as shown here. So I will also be using the iris dataset as an example, like we've seen before, with some different species of irises and information about the sepal and the petal lengths and widths. So I will start by introducing you to some useful first steps of getting to know your data and checking variable types, for example, which will help to avoid some errors. And then I'll go through a few examples of getting descriptive statistics, getting correlations, one-way Anova, logistic regression, and a brief introduction to the two-way Anova. So if you are following along on your RStudio Cloud or RStudio, I'm using the file called p2p_stats. You'll also have the option of observing now and using this file for your reference later. So we've already installed the packages that you need, but here's some code that you could run if you needed to load your packages. And we've installed the iris dataset. So oftentimes you might be working with a data set that is unfamiliar or partially unfamiliar to you. Other times you might have loaded a data set that you know well into R for the first time. Either way, it is important to check the variables, variable types, and dimensions of the data set first. So for example, as we've seen, you can see how large the data set is by running this code. And here I can see that the iris data set has 150 rows and 5 columns. So this next chunk of code will list the variable names and types from the data set. An essential step is making sure that the variables are saved as the correct variable types. For example, if you try to run a statistical analysis and your variables are saved as character types, you will receive an error message. So it's good to double check this. You can see the variable names. You can see right here is the variable types, and then you can get a little bit of information about some of the values that are stored here. So if needed, you can convert the variable type. For example, this first line shows how I could convert a variable to factor type if needed. And the next line shows how I can convert a variable to numeric type. And this line of code will show me the first few rows of my data set. So once I have a good set of the data frame and know that the variables are saved as the correct variable types, I can start looking at some descriptive statistics. I can print out summary statistics, including mean, median, minimum, maximum, first quartile, and third quartile by using the summary command in R. So in parentheses, I put the name of the data frame followed by a $sign and the name of the variable. I can also save output as an object, like in this line. And that way, anytime I type the name of the object, I can print out the results. So this chunk of code shows how to run it both ways. The next, as we discussed in the previous one, I can use this pipe operator to get summary statistics by category. So here I've shown how to get the sepal length from different summary statistics by species. So another thing I'd like to point out in this code is this parameter here. It says na.rm equals true. So this card tells R to ignore any missing values while doing the calculation. Although missing values are not an issue when working with complete example data sets like IRIS, we typically have missing values in our data set. And sometimes this will trigger error messages if we don't handle it. So one way to make sure that R will ignore those missing values is to use this parameter in your code. So now let's run some statistical tests. I might want to find out if sepal length and sepal width are correlated. To get a correlation coefficient and p-value, I can use the function core.test. I can specify the method. So here I have specified Pearson, but I could also specify other methods like Spearman or Kendall. So in my output, the correlation coefficient is here, and then I can look up here for the p-value. This also prints the 95% confidence interval. So because the lower and upper limits of the 95% confidence interval include 0, it makes sense that this correlation is not significant. For small data sets like this one, I might want to check the bivariate correlation of each numeric variable to each other numeric variable in the data set. I can use this correlation function to get a correlation matrix with coefficients and p-values in this column. So I can also run a one-way Anova. For example, this chunk of code, I will test whether there is a significant difference in sepal length between different species. To do that, I first use this line of code to fit the model and create an object for that model. I run the next line of code on that model to test for significance. So I can check the output for the F statistic and the p-value. Since the omnibus one-way Anova test gave us a significant p-value, I can follow up by running some post hoc analyses. So this chunk of code here demonstrates how to run pairwise t-tests on each of the variable pairs. I can look at the unadjusted p-values. So this approach is shown in the first line of code, or I can look at adjusted p-values by specifying the method I want to use. In this second line, I used the Bonferroni method. So the next chunk of code demonstrates logistic regression. For example, I could use this code to test how well different variables in the iris data frame predict petal length. The first line of code fits the model and saves it as an object. Well, the next line tests the model for significance. For factor variables, the first category that's included in the data frame will automatically be used as the reference category. So finally, this last chunk of code gives an example of how I would approach, how I would get started with a two-way Anova. This is using another data set, which is also included in that Google Drive folder that is available to you. So feel free to practice that on your own. So an important part of running statistical tests in R is visualizing the data. Creating data visualizations can help you to examine your data to make sure that no assumptions of your statistical test are violated, to interpret your results, and to communicate your results to an interdisciplinary audience. I'm going to hand this off to Vishwan, who will introduce you to data visualization using R.
Thank you, Leslie. So now I'm going to talk about a very popular package for data visualization in R. Hi, Shams. It seems like I cannot click the other. Oh, it worked. Okay, so so what is ggplot2? So ggplot2 is a package. ggplot2 is a package. Sorry. ggplot2 is a package that are generated for R data visualization, and is based on the grammar of graphics. So the grammar of graphics is a book that's about making graphs and plots in R by break up them into different components such as scales and layers. And ggplot2 was initially implemented in 2005. And since that, it quickly became one of the most popular R packages. So here is the summary of the top 10 most popular packages that are downloaded in April 2015, and ggplot2 is the second most popular one. And from 2012 to 2017, ggplot2 was downloaded over 10 million times. And today we're going to learn how to use ggplot2 to generate simple scatter plots. So we should keep in mind that by using ggplot2, every graph is generated based on 3 components. We should have a data set, and we should use a coordinate system. And then we should have geoms, which means zero marks represent data points. And at the end of this tutorial, you will be able to generate a simple but nice scatter plot like this one. Hi, Shams. It seems like I cannot click on my computer. Can you give the control to move that I will use for computer? Sorry about the inconvenience. So now I'm going to show you how to make plots using ggplot2. So first, if you haven't installed ggplot2, we can run this block of code to first install ggplot2, and then we import the library to our project. And after that, we will continue to use the iris dataset that was introduced before. And this is a dataset that is very popular in some statistical and machine learning analysis. And many people are using this dataset to give tutorials about very different models in machine learning. And if we look at this dataset, we see that there are 4 different features. For the iris samples belong to 3 different species: the iris setosa, the iris versicolor, and the iris virginica. And since this dataset can be used to train models to build simple classifiers for different species, today we will try to look at whether different species have different features. So first, before we move to ggplot2, let's see a very simple scatter plot generated by the plot function that is the built-in plot function from R. And by running this block of code, we see that this one line of code generates this scatter plot. And we see that here each plot represents one sample, and there might be some overlapping samples with the same data. And here we have only two lines of code, and this here we're using ggplot2 to generate also a scatter plot. So this time we also use very few code, but this time we see that in the scatter plot we use different colors to represent different species. And we also have a different color as the background. So now let's see how we can generate a nice plot by ggplot2 step by step. So first, let's initiate a graph. So in this block of code, we initiate graph using ggplot2. And this time we just initiate the plot with a coordinate system. We tell ggplot what data we want to use, that's the iris dataset, and we use the AES to tell ggplot2 which variable we want to use as the x-axis and the y-axis. So here we have a blank plot, but we have the x and y-axis. And then we try to add another layer to tell ggplot2 that based on this x and y-axis, we want to make a scatter plot. And so we use a geom point. And this time we see that we have points representing different samples. But as we see before, we want to use different colors to represent different species. And so inside the geom point, we also use another AES to tell ggplot2 that we want to assign colors and shapes to the species. And by running this code block, we have the data sets represented by different colors and shapes. And in this plot, we still use the variable name from the dataset as the x and y axis. And to make the plot easier to read, we try to change the name of the x and y label, and we add a title to this plot. So at the end of the geom point, we tell that the ggplot that we want the label for x and y axis, and we want a title. Oh, sorry. We want you to assign a x and y label and a title. And then we can also use different styles of themes in ggplot2. So ggplot2 has a lot of built-in themes. One of them is theme minimal. So let's try this one. So this time we generate plot with some lighter background. And in ggplot2, they provide some built-in themes to use light or darker background. And we can also customize our themes. So this time, after applying the minimal theme, I also tell ggplot2 that I want to fill the background with a light blue color. And this gives me this plot. That's the same one as the beginning of this tutorial file. And because ggplot2 is very popular, there are a lot of extensions developed to help us to generate even nicer plots. So there's one package as an extension of ggplot2 called ggthemes. So after we install the package ggthemes, we load the package and we try to use a theme provided by this package called the economist. And if we run this code block, this time we see that the plot seems more professional. There's a different grid style, and the legend moved to the upper than the right of the plot. And we can also, so besides those extensions, we can also change different color styles for our scatter plot. For example, this time I tried another color style called Pastel 2. And because this coloring style uses very light colors to make it easier to see, this time I choose a dark theme from ggplot2. And in ggplot2, we can also use some statistical method to help us to make, for smoothing, to help us to see the trend of the data. So here I'm showing two methods for smoothing. So the first one is that using to build some lines to show the trend of this our data. So here, for each species, we try to fit the data to a linear model, and we see that different species has different relationship between the sample width and sample length. And we can also use some curves to represent the trend. So ggplot2 also provide function to apply polynomial smoothing, and this time we have 3 different curves. And also sometimes we want to put multiple plots in one figure. For example, here we have different species. What if we want to show them separately? So ggplot2 also provide Facet function to help us to break the whole figure into different pieces. So this time we try to represent different species into different rows in this whole figure. So to do this, we at the end of the previous code, we add the Facet grid function, and we specify that we want to use species for each row, and we want to use nothing for each column. So here we have this figure, and if we want to use different columns to represent different species, then we just change the value we provide here. So here means we use nothing for rows, but we use species for the columns. So now we have the Facet grid figure. And after we generate those plots, we want to save them so we can use them in our presentations or our papers. So in ggplot2, the figure saving function is called ggsave. If you just call the ggsave function, and provide the path and the name of the file name you want to save the plot as, then this will just save the latest plot you just make, which means this one. And if we generate multiple plots and we just want to save a specific one of them, then we can assign the plot to a variable. And then in the ggsave function, we provide both the path and the name of the variables, so we can save the specific plot we want to save here. So now it will tell us that we saved our plots. So now I will give it to Muzi to talk about how to generate more fancy interactive plots.
Okay, so Bishan has talked about like how to generate beautiful plots using ggplot2. But what if we want to interactively visualize a plot? Then we want to use Shining. So Shining is an R package that make it easy to build an interactive web application from R. And we can see the R Shining website includes different components such as get started, gallery, and articles. And the Shining gallery shows the application of Shining packaging in different areas. For example, it can be used to build COVID-19 tracker and to display MRI images. What's more, Shining can also be used to design online games. So if you want to know more about the Shining, you can visit the Shining website and watch the video tutorials or read the written materials. So next, I'm going to talk about how to build a simple Shining app. The web application here shows the correlation between two selected features of a selected flower species using Aries dataset. So the first step is to create an R file called app.r. You probably can find it in your Google Drive folder. And then we want to load the Shining and the ggplot2 packages and the Aries dataset. If you haven't installed the package Shining, you can use this command line to install it. And then we want to define the user interface and the server. That's the basic structure of the Shining web application. So a Shining app is mainly composed of 3 parts. UI, that's the user interface. Server, that's the brain of our web application. And the Shining AP, like an app, is used to run the web application. So first, we want to design the appearance of the web application. That's the user interface. So here we can see the title of the web application is Aries here. And then we want to use sidebar layout. So the sidebar panel includes 3 select boxes, species, feature 1, and feature 2. So each of the select box will have its own unique input ID, SPEC, F1, and F2. And the main panel will display the scatter plot. And the scatter plot here will also have its own unique output ID, that's plot. So in our tutorial, I only use the select box here. But when you build your own web applications, you may want to use other functions to implement other useful control widgets. So after we have the user interface of the web application, we want to design the content of our web application. So we want to use the reactive expressions. The data variable here is a reactive variable, because it will change based on what species we choose in the first select box. For example, here, if we choose Setosa, in the first select box, then the value setosa will be passed to input $SPEC. And the SPEC here is the unique input ID of first select box defined in the user interface. And then the data here will only include the setosa data. And then we want to use the ggplot to draw the scatter plot using the data generated above. And the x-axis will be the feature 1 we select from the second select box. And the y-axis will be the feature 2 we select in the third select box. So the scatter plot generated by the ggplot will then be passed to output $plot, and then eventually be displayed in the main panel here. So the plot here is the unique output ID of the scatter plot defined in the user interface. So if we put all those code together, we will see we use less than 36 lines of code, but generate a simple interactive web application. So you can find the app.r file in your Google Drive folder, and then you can upload it in your R Studio Cloud, and then you can simply click this run button, and then you can see the web application. So since our case is a very simple case, but when you build your own web application, you'll face other difficulties. So here I list a few communities that you can visit and seek for help. So in conclusion, Shining is a well-maintained and easy-to-use package designed for data visualization. So this is the last section of our Intro to R tutorial. So if you have any questions, please feel free to ask.